Okay, thank you, presenters, for those recorded videos and for joining us here now as we cross the morning into the afternoon here before lunch. We do have some questions coming in that I'll ask the panelists for. The panelists should have access to their presentations and be able to share their screens as needed if it's useful in answering a question. So thanks everyone again. The first question is going to be from Moochul. This is coming from Stephen Piper. He found your work. He makes a comment that your work is interesting, and he breaks his inquiries into three questions. The first question is how are these fibers superior to other micro, macro, and hybrid polyfibers? All
Uh,
right.
uh, okay.
And then I think you'll be able to answer the other two kind of in as you answer that. But he also asks, why is your design water cement ratio at 0.45 when you can easily design it at 0.38? And with the inclusion of super plasticizers. And do you see any evidence of scaling? So three questions.
Just start from the easiest one, the last question. I haven't seen any scaling, so we've been testing or mixing the concrete and making out cylinders and samples and beams for years. So we recently tested a year-old cylinder. Even then, we didn't see any scaling. And then I think I can make a comment whether this is more superior to the other types of the plastic fibers, but one thing that we really cares at the time, where even now, is the walkability. So adding the fibers, it has much more surface area. We are not mixing to the just regular concrete. It is to the high performance concrete. As the concrete performance increases, the walkability decreases. So again, with that in mind, the fibers we chose, we tested it, has an excellent workability. Not only that, the dispersion is well distributed. And then another concern is that many fibers we have, not I have it, but when we try to mix the fibers to the concrete, the structural integrity of the fibers. It can be broken during the mixing steps. So when we try to work with the manufacturer of the microfibers, they recommended to use the drum mixer. But again, drum mixer, the power itself will not be high enough for the high performance concrete we have developed. So we said that we're gonna test it, but we are required to use the shear mixer. So when we tested with the shear mixer, we didn't find any evidence of the breakage of the fibers, and it's well mixed, it's well distributed, and there is no segregation. And again, if you try to use the fibers a little bit plastic side, plastic fibers, they tend to clump together. So that was another concern that we had it. But this fiber has a good specific gravity, as well mixed with the concrete that we are using. And it showed a great performance and potentials in many aspects. And then water cement ratio, again, Y.45. In fact, that's where we started, when we just start mixing the concrete with the microfibers that we testing. So again, the walkability was the issues, but when we moved to the high performance concrete, again, we are using between 0.2 to 0.3.
Thank you. And just because we're on this topic, I think it's a relatively quick response, but we also have a question, have concrete ties been used in cold climates? If so, how long have they been in service? What is their design life?
Our concrete, we haven't made a concrete cross tie with our mix yet. That's the goal. We test all the mechanical performance and durability, and we would love to do the freeze thaw, but we don't have that. But unless we can do the corrosion test, and then once it's confirmed that we would like to manufacture in a full scale. So
But have concrete cross ties been used in cold climates?
Many other countries, European countries, Russia, they have concrete cross ties. Even Asian countries, including Japan and South Korea and China, there are regions that has a cold climate, but they've been using concrete cross ties in many aspects, more than a
So that
wooden ties. Yes.
so there is some precedent there
Yep.
for that. Okay, that's great. Thanks, Moochul. We have some questions related to the final presenter, Dr. Lopez-Anido. There were a couple that were already answered essentially, but there were questions. So I think I can answer them myself. Are you printing the forms, but not the Portland concrete part itself? I believe the answer there is yes. This presentation was about the forms, so it wasn't talking about the reinforced concrete part. And what fibers have you been tested with? The answer is carbon fibers. One of the final questions, though related to your work, Roberto, was what is the impact of temperature and humidity on this printing process or the formwork itself?
Sure. For the material that was selected here in the application, that are carbon fibers ABS, this material does not absorb any significant amount of water, for example, when casting fresh concrete. And therefore, there is not a significant impact on the short-term mechanical performance. The other concern with regard to temperature, we know there is a heat of hydration temperature in concrete. However, that temperature is lower than the temperature at which this material will become softer. It's called glass transition temperature. So there's not really a risk of have a significant impact on the performance of the formwork in the short term for the precast concrete application. Now, the question for the long term is different, and that is the subject of an ongoing study. For other type of applications where the material is exposed in an exterior environment to sustained moisture or humidity, as well as higher temperatures. In that case, what we are doing is accelerated testing in the lab, and we're coming up with what properties, mechanical properties can be affected. For example, we're looking at flexural strength and what percentage of those properties are retained when we conduct standard accelerated tests.
Thank you, Roberto. Yeah, so ongoing work on that part and those longer term questions. That'll be very interesting. I'll pose a question here. Oh, we have another question for the formwork here. For the formwork, is there any guesstimate on how many more times they would have been reused? And just related to that question, I'll just piggyback on it. How often is a piece of framework reused? Just generally for normal framework. So I'll jump on that.
Okay, yeah, that's a great question. We have a parallel project going on with another producer, with Unistress Corporation in Pittsfield, Massachusetts, where they are using smaller forms, but for an application has multiple uses. These are window frames for precast concrete walls, a product they call light wall for parking garage structures, where they expect to see at least 20 uses, if not more. Once we gather the information, we'll have a better estimate on the longevity of the material in terms of number of uses. For the application that we presented, the railroad bridge ballast retainer, I don't foresee that a formwork would be used many more times because there are more custom applications for the particular project. What becomes important, I think, here is the ability to then recycle the material, meaning basically shred the material, be able to pelletize it, meaning bring it to a form where we can feed the extruder in the large format 3D printer and print it again. So, and that is the subject of a current project where we want really to be able to recycle all that material that was used in the project we presented.
Oh, thanks, Roberto. So I'll jump on, and we don't want to leave out Ramesh and Celso here. So I'm going to follow up with a question here related to your guys' project. You've done a lot of testing, monitoring, and finite element analysis of these railroad bridges, and you're kind of looking for the durability and really how much longer we can expect them to remain in service. Something I'm always thinking about, and I potentially asked this in the past, but a lot of times these bridges fail at the connections. And I know that you've grabbed intact samples, and you guys have tested it, and I'm sure the strengths are comparable to what were expected when the bridge was new. But how is your monitoring and finite element analyses capturing where we often see failures occur, say at the connections or elsewhere? How is that being used to inform that, you know, those sensitive locations are performing as intended? Or is there something else that you plan to do in the future to capture that?
Aran, thank you very much. I think very good question. That's our final goal. Right now, what we are doing is we're modeling global way, you know. The key thing here is we want to update our final element based on our test results so that we have very good final element which will represent the global nature of the bridge, you know, under the service load. Now, once we have the good final element model, then what we can zoom into is the members. So we know exactly the load the member carrying, or the load or the forces the connection carrying, right? And then we can zoom into the particular member, which may be critical in a sense of load carrying. Then we can do more analysis and see what kind of remaining life it has, or how much is stress beyond its original capacity. So that's the goal. So right now we are field testing, updating a final element. We're getting into representing the bridge as it is now. And then next phase of study, one of the slides I had for future study, because shortage of time, we eliminated that. But we have another project going on, which really looks into what you are talking about. Going into the member connection, my connection, joint connection in wear and tear situation. So that's what we're zooming into. That's ongoing work.
Thank you, Ramesh. It's 12:31. It is the end of this session here before lunch. So while there are some questions remaining in the chat, the contact information for the researchers are available on the TIDC website. I encourage you to reach out to them if you still have questions and inquiries about their presentations today. I want to thank all the presenters for joining us, providing those presentations, and joining us for the panel discussion. Everyone have a great lunch, and thank you all again. Have a great afternoon.
Thank you for the opportunity. Thank you. Bye-bye.
Thank you.